coordinate plane. When you see the word distance, what other math word do you think of when we talk about distance on the coordinate plane? What do we know about distance? We could measure it along the x-axis or measure how far it is from the x-axis. What else? You think of distance, like how far away it is from the x-axis or how far away it is from 0. All day everybody's been struggling with this. Monday after vacation.
I remember DTR. Distance.
Oh, sure, that was a formula a long time ago when we did ratios. Time and rate, absolutely. But what else do we know about distance on the coordinate plane? What's another word if we wanted to see how far something was? That's the word I was thinking of, absolute value. So today we're going to let absolute value help us figure out distance. Do you remember back when we saw this guy fishing? And we looked at the water as if it was our x-axis, right? It's the top of his fishing pole. But let's actually imagine, first of all, that it's a coordinate plane. All right, let's just go ahead and make it a coordinate plane. So if this was -2, 5, and the end of his fishing line was -2, -6. I'm just making up numbers. So if anybody's wondering, where did she get that from? My imagination. Okay? So what is the distance of his fishing line that's out of the water? What's that distance? How far above the water is his fishing line? 5. Let's go with feet. 5 feet, right. But what about this part down here below the water where the poor fishy's going?
6.
This is 6 feet below water. So what do we know about the whole fishing line?
Isn't it negative?
Can distance be negative? That was an awesome question. Can distance be negative? No, because it's still 6 feet. It doesn't matter if it's 6 feet this way or if it's 6 feet that way. It's still 6 feet of line. If I pulled it out of the water, it's still 6 feet of line. Okay? But that's something that actually ties in nicely. Let's start by looking at, so we said the whole rope was what? The whole fishing line was 11 feet. How did you get 11 from 6 and 5? Right, 6 plus 5 is 11, so it was a total of 11 feet of fishing line. We did that before. But what I want to do is really take a look at these ordered pairs and see what we can learn from the ordered pairs. What do we notice the two ordered pairs have in common? They both have the exact same x-coordinate. They both have -2. So when their x-coordinate was the same, what type of a line did we end up getting? Vertical line. So when your x-coordinates are the same, you're going to have a vertical line. But since our x-coordinates are the same, we're not going to focus on those. What we want to do is look at the coordinates that are different. Do they have the same sign or opposite signs? I shouldn't say different signs. Do they have the same sign? Are they both negative? Are they both positive? Or are they different? They're different. One is positive, one is negative, which means it crossed over the axis. Because one is positive, one is negative, that means it's on opposite sides of the axis. So what we did was we looked at the distance from 0. That distance from 0 was the absolute value of 5. Now here's where your excellent question came in. This is the distance from 0. So distance from 0 is absolute value. That's the word we were looking for before. So the absolute value of -6 is 6. The absolute value of -6 is 6. So we took our two absolute values and added them together to get the total distance. Right? Any questions on that? Let's suppose He had another fishing line over here. So this was, I don't know, 4, 5. But because he fell asleep, he didn't drop it in the water. So it's still above the water. How long is that fishing line? Let's take a time out. First of all, what do we notice about our ordered pairs? What do they have in common? What do they have in common? Because they have the same x-coordinate, that creates a line that is vertical. So we're going to take a look at our coordinates that are different, the 5 and the 2. If we had a regular number line, remember in kindergarten you had your number lines and a little frog would hop up and down the number line? How many hops would it be from 2 to 5 on your number line? Everybody? 3. So this does have a distance of 3. But what operation would we use? Over here we use the operation of addition. Would I use addition here, the 5 and the 2 and the 3? Right, so we have the absolute value of 5, the absolute value of 2, and now we subtract them. Because if this was our number line, well, it is a number line, 1, 2, 3, 4, 5, this is 5, but we're not counting the first 2. We're only counting those. So the difference is, if your coordinates have different signs, you add them because they're crossing the axis. So if they're crossing the axis, you have to add. If they have the same signs, you're not crossing an axis. You're staying in the same quadrant. So if you're staying in the same quadrant, you're going to subtract. We're going to practice this some more. Let's take a look at some more examples to see what this means. Let's take a look at example 1. Okay, down in the middle of page 68. In the middle of page 68, we have a number line here, -4, 0, and 5, 0. So what do we notice about these two ordered pairs? What do they have in common? So now this, we're going the other direction. If they have the same y-axis, the same y-coordinates, what type of a line is it? Horizontal. Okay, so if it's the same y-coordinate, it's a horizontal line. Well, I can count this on my number line, 1, 2, 3, 4, 5, 6, 7, 8, 9. But suppose we don't have a number line, or suppose we're working with really huge numbers. I want to be able to figure that out just by looking at my two ordered pairs. So instead of looking at what's the same, let's look at what's different. Since one is a negative and one is a positive, I know that we're crossing the axis. So because I'm crossing the axis, I'm almost creating two number lines if you want to think of it that way. You have this one, and you have this one. How would I write out the distance from 0 to -4? Right, so if we had the absolute value of -4, then we have to add to it the absolute value of 5. So the absolute value of -4 is, the absolute value of 5 is, so the total distance is 9. Let's try one more by looking at a number line. So here we have our ordered pairs 0, -6, and 0, -11. So what do we notice about this ordered pair? What do they have in common? They both have the same...
They both have the same x-coordinate.
Right, so because they have the same x-coordinate, it created a vertical line. But we're not going to look at what's the same to find the distance. We're going to look at what's different. Are those both positives, both negatives, or are they different signs?
Both negatives.
They're both negative. So what does that tell us about their location? It tells us they're on the same side of 0 and that we did not cross an axis. Since they're on the same side and we did not cross an axis, we're not going to add, we're going to subtract. So we have the absolute value of negative 11 minus the absolute value of negative 6. So 11 minus 6 is 5. Because we don't want to use the whole 11. Because those don't count. We didn't include those in. It's only from negative 6. 1, 2, 3, 4, 5. You should be writing this down on the top of page 69 or in the middle. The middle. Any part of 69. That's okay. So take a moment and copy this on the top of page 70. The same x coordinates gives you a vertical line. The same y coordinates give you a horizontal line. On top of page 70, write that, and that'll help you out a little bit. Because in the exercises, it asks you not only to find the distance, it does ask you if it creates a horizontal line or a vertical line. So at the top of page 70, please copy this in red and blue. The same x coordinates give you a vertical line. The same y coordinates give you a horizontal line. All right, let's continue. Now you notice on your paper you don't have coordinate planes because you don't need them. We're getting away from coordinate planes and we're just going to look at the ordered pairs to figure out distance. If you want to sketch a rough one out in the margin, personally I'm a visual person. I like to see it. So if our first set of ordered pairs are negative 3, 4, and negative 3, 9. So negative 3, 4, negative 3, 9. I would definitely take out 2 colored pencils or 2 highlighters for your homework tonight. So what do we notice are the same? So if our x coordinates are the same, what kind of line is it? Vertical. So that's the first thing you're going to do. It's a vertical line. But the coordinates that are the same are not going to help us with the distance. So we have to look at the coordinates that are, different. Whoops. Let's try this again. No more whoopses. There we go. Since those signs are the same, did we cross an axis? No. So are we going to add or subtract? Subtract. So we have the absolute value of 9 minus the absolute value of 4. 9 minus 4 is 5. So you're writing all of that down for A on page 70. Please show all 3 steps, the absolute value, then show the value, then show the distance. So first identify the line, then the equations, both steps, and then the distance. Okay, let's try B. What are they saying, the x or the y coordinates? So that means it's a horizontal line. Our x coordinates are different. Are they the same sign or are they different signs? So what does that tell us? That they're different signs. Why? What does that tell us about the 2 points? Right, they're on different sides of the axis. They're in different quadrants. So therefore we need to add the 2 distances together. So we have the absolute value of 2 plus the absolute value of negative 8. So 2 plus 8 is 10. Over 2, down 2, negative 8. Down 2. If it helps you to sketch it out, you can sketch it out. That's up to you. Double check it. If that helps, but the whole purpose of this is to get away from counting spaces. You ready to try the next one? Let's do one more together, then you can try the last two on your own. So which coordinates are the same, the x or the y? X, so that means it is a vertical line. So we're going to look at the coordinates that are different. Are they the same sign or different signs? So because they're different signs, that tells us our line does what? Same quadrant or crosses the axis? Crosses the axis. So am I going to add or subtract? Add. If you're not sure, think about our fishermen. You want to sketch out a rough line, you can. And then try the next two on your. So let's go over the last two. We're going to focus on the ones that are different. So I have the absolute value of -9. And I'm using absolute value because we're looking at distance. Absolute value is distance from 0. Are these on the same side as 0, or are they on opposite sides of 0? They're on the same side of 0 because they're both negatives. So they're the same sign, we subtract. So find the absolute values. And if it helps, -9, +4, -4, +4. Oh, and I forgot to write that it was a horizontal line. Because I don't want the whole 9 because that part's not included. I only need part of the 9 because it didn't go the whole way. The last one, I have the absolute value of -11, the absolute value of 8. Am I going to add them or subtract them? You should be writing this down, especially since you didn't understand it at first. My signs are different, so I have to add. So the absolute value of 11 plus the absolute value of 8 is 19. And since my x coordinates are the same, that created a vertical line. Over 0, -11, over 0, up 8. So because they were on opposite sides, it's almost like I have two different number lines that I have to add together.